G'day and welcome back to RC Model Reviews. Today I want to talk about nitro engines. Yeah, I've had enough of talking about FPV and mini quads and stuff for a while. Let's talk about something, go right back to basics. And this, for a lot of people watching this channel who are fairly new to the hobby, this is probably something you haven't seen a lot of. Nitro used to be the backbone of the hobby. Just every powered model aircraft had a nitro engine in it because electric just wasn't a thing. You know, a few decades ago, we just didn't have the batteries, we didn't have the motors, we didn't have the electronics to make the speed controllers. So we had to fly internal combustion engines, and nitro engines were the go-to engine for that. Of course, since then, things have changed. Now electric is more powerful, it's more convenient, it's cleaner, it's lighter. It's just got so many benefits that nitro's been kind of pushed into the back of the hobby. And apart from a few old codgers like myself, not a lot of people fly nitro, but it is still part of the hobby, and I'm pretty sure that a lot of people who are new to the hobby may have an interest in just how these things work and what's involved and whether all the rumours they've heard are true. So in today's episode of RC Model Reviews, we're going to look at nitro. Okay, so modern, well, when I say modern, yes, these are modern. You can still buy some of these engines. They're not all relegated to the scrap heap. But a modern nitro engine is simply a way of converting a liquid fuel, which consists of nitromethane, methanol, and castor oil, into power. And these engines like this are normally measured in terms of horsepower. This is probably about a 1.5 horsepower engine, which equates to about 1200 or 1300 watts in electric terms. And but of course it's slightly different. Internal combustion engines have a much different torque curve. They have to reach a certain number of RPMs before they put out peak power, whereas electric motors produce full torque right from stalled. So if you're flying a model with a nitro motor, it's a lot different to an electric motor, for reasons that we'll go into a little bit later as well. But suffice to say, there are probably two basic types of engines, model aircraft engines, that we use. We have two strokes. This is a two-stroke. This is a two-stroke, and we have four strokes. These are four strokes. Now, the four strokes are, let's look at the differences. Four strokes are generally heavier. They are generally more complex. They're generally more fuel efficient, and they're usually quieter. So yeah, that's probably about it. So these engines here also produce their power at lower RPMs. For example, the Saito 82, I think the maximum power is about 10 or 11,000 revs. This engine, which is a pylon racing engine, typically 22,000 RPM, so that's a huge difference. A sport engine like this, another two-stroke sport engine, it's probably around the 13 to 14,000 RPM, but it's still a lot higher than the four-stroke engines. So, you know, if you're looking at in terms of electric motor terminology, these are low kV, these are high kV. So that's the way, if you want a model that flies really fast, then you want to use a high revving engine with a small propeller. It gives you a high, what we call pitch speed. If you want a model that has lots of static thrust, so therefore it'll climb well and it'll accelerate well from a standing start, in these are your engines. So you tend to use these on things like 3D or scale models, these on racing models or trainer models. So yeah, but there's no hard and fast rule. You can use, I've got a P51 Mustang which flies really fast, and it's got a four-stroke in it. And I've flown 3D models with two strokes in them. So it's, you know, it's just whatever you seem to think or want on the day. You know, what you've got is what you use. So let's talk about the magic that makes these things happen, because we use the word nitro to describe these engines, but they're not actually nitro engines. In the days of past, we called them glow plug engines because they have a glow plug. If we look, each of these engines there's a glow plug in the top of this one, there's a glow plug in the back of that one, and there's a glow plug on the side of this one. This has got a hole for a glow plug. I haven't fitted one at the moment. So they all have glow plugs. And what is a glow plug, and why is it different to a gas engine? Well, glow plugs, like spark plugs, come in a range of different sizes and flavours and so forth. There is pretty much a standard, I think it's a quarter 32 thread, which takes a standard glow plug. So we've got a number of manufacturers still make these things. We've got OS, this is an OS 2-stroke glow plug, an OS 4-stroke glow plug. This is Enya, this is one of their two-stroke plugs. This is just a Hobby King cheapy brand glow plug. They all do basically the same job. Generally speaking though, the more you get what you pay for. If you buy a cheapy Hobby King plug, it's a rebranded, I think they're probably an ASP plug, and that means that they don't use the same quality materials, so they won't last as long. They may not give quite the same performance. And to understand how that works, you need to know what a glow plug is made of. A glow plug is a body like a spark plug, but instead of having a gap, it has a coil of wire. There's a coil of very fine wire, and it's probably easy to see in this one. Let me just go to macro and we'll pull it on this one. You'll see what I'm talking about. Now, if you look in the center of this glow plug, you'll see a little coil of wire, a very fine wire wound into a coil. It's a filament, and that wire serves a really, really important role with your glow plug engine. That is responsible for being the catalyst for the ignition of the air and fuel. Once the piston comes up to the top of the cylinder and the air and the fuel's all compressed, that little wire has just enough heat to cause it to ignite. So there's no sparking involved, it's all done by heat. And the composition of that wire is very important because it relies on a chemical catalytic reaction. Basically, if you have alcohol fumes in the presence of platinum, then the platinum will get hot. It will get hot because of the catalytic reaction as it breaks down the methanol. Effectively, it burns the methanol by causing it to combine with oxygen, and you get this heating of the filament involved. So that's what causes the heat for ignition. But when we start an engine, the filament isn't hot enough to start this reaction. Like most chemical reactions, it's something that the hotter it gets, the more active the reaction is. So when the engine's cold, it won't start on its own. You've got to heat up this little plug, make it glow first to get the engine going, because once the engine's running, the heat of combustion also helps keep this little tiny filament of wire glowing. Now, in a very cheap glow plug, this tends to be of poor quality. And in the old days, we used to get glow plugs that were basically solid platinum. The filament was solid platinum wire, and that produced very good results, but very expensive. Platinum's an incredibly expensive metal. So what tends to happen these days is we have a base metal, a piece of wire, and then they apply platinum alloy to the outside of that wire, because that's the only bit that reacts. The center of the wire isn't exposed to the alcohol, so it doesn't matter if it's not platinum. And what happens is, the better quality the plug, the thicker the platinum coating, because over time it will erode and wear off, and once the platinum's gone off the wire, the glow plug won't work properly anymore. Typically, symptoms are the engine will start, but when you take off the glow plug connector, the battery that heats up the glow plug, it will cool down because there's no longer any catalytic reaction to keep it warm. So the engine will stop, or it'll run rough, or it'll be unreliable. So high quality glow plugs, such as the ones from Enya and OS, they tend to have a much thicker coating of platinum than the cheapy plugs from Hobby King and ASP. That's a little thing to know about. So one of the key things, when people have trouble with glow plug engines, the first thing you should do is try a new glow plug, because quite often it's just the glow plug is faulty. Very rarely do they actually burn out and go open circuit, but quite often the catalytic material on the surface is eroded away by combustion and so forth, and they become non-catalytic, and therefore they just do not work properly. Now, as we can see in this engine, there's a whole thread in the top that the plug just screws into, and to start a nitro engine, all you need to do is heat up the plug and spin the engine over with fuel. It will run, and as I say, once it starts running, then it will just continue running because the plug will stay hot through the catalytic effect and the heat of combustion. Simple as that. So every glow plug engine has a glow plug, and that's the secret. So the word nitro is a bit of a misnomer, because what's happened is nitromethane is a fuel additive. It's not the fuel, it's a fuel additive. In fact, I've done a video, I think, is it on this channel or my other channel, where I show you can't even light. If you pour nitromethane into a bowl and try and light it with a match, it will not burn. It's not a very good fuel. The reason nitromethane is used is because it carries lots of oxygen, which helps the fuel, which is the methanol, helps the fuel burn. If you have extra oxygen, you can use extra methanol and put more fuel into the motor so that you get more power out. That's simply how nitromethane works. In Europe, Australia, New Zealand, countries where nitromethane was previously pretty hard to get hold of, we usually ran these engines just on methanol and oil. We didn't have any nitromethane at all, so that's why they were glow plug engines, not nitro engines. Of course, in America, nitromethane has been freely available and relatively cheap for many, many years, so they use high nitro contents. Now, one thing you might wonder about with this whole setup is, if you understand how engines work, you know that in a gas engine, the timing of the ignition spark is quite critical to the performance of the motor. Generally speaking, that timing can be advanced, which means the spark occurs earlier, or it can be retarded so that the spark occurs later in the cycle. We really want the fuel to ignite just as the piston hits top dead center, because at that point, any pressure applied to the piston will go into continuing the rotation of the crankshaft and producing power at the propeller. In the case of a gas engine, it's easy enough to do. You can just adjust. In the old days it was points, but in these days electronic ignition and modern computer electronic ignition automatically advances and retards the spark based on revs and so forth. Very, very complicated. These are the utter simplicity. There is no timing control. There's no way. You've just got a piece of hot wire going to set off a flammable mixture. So how do you adjust the timing for best results? Well, that's where these different choice of glow plugs come in. We have hot plugs, we have cold plugs. And a hot plug will, as the name suggests, glow more hotly. So it will ignite the fuel sooner. As the piston is coming up, it'll reach a point where it ignites the fuel at some stage in that combustion cycle, and the hotter the plug, the sooner it ignites. So that advances your ignition. If you have a hot plug, you've got advanced ignition. If your engine is igniting too soon and it's doing something called detonating, we know that in a car is pinging or knocking, then you use a colder glow plug. And therefore the fuel won't ignite until the piston has come further up and it's actually past top dead center. So that's like retarding the ignition. So proper choice of glow plug is pretty important. Now most sport motors like this, it's not as important as you might think, because there's a fairly broad range of operating parameters, and this OS number 8 or the Enya number 3 are basically pretty standard sport plugs that you can use in almost any sport engine without having to worry too much about it at all. The other things you can do is you can adjust the reach of the length of the glow plug. We used to have short, long and medium glow plugs. Most glow plugs these days are medium, but a longer plug will give you slightly more advanced timing. And in fact, the 4-stroke plug, if you look at that, might be hard to see through the packaging, but the 4-stroke plug is actually quite a bit longer than the 2-stroke plug, because 4 strokes only fire once every 2 revolutions. So you need to retain the heat for longer. You need to have a hotter plug, because the second time the piston comes up, there's nothing to burn. It's just pushing exhaust gases out. So if you use a cold plug, then when you come around for the next combustion cycle, the plug has got too cold and the engine won't run. So we generally run a pretty hot plug with a 4-stroke. And sometimes that means it's also got to be a bit longer. Little things you probably didn't know. So let's take another look at the difference between the 2 strokes and the 4 strokes. At 2-stroke here, as you can see, it's pretty simple. It's only got 3 moving parts. It has a piston. Here's a typical piston. It has a connecting rod, which is attached as a piston, connects it to the crankshaft, and of course the crankshaft. So you get crankshaft, connecting rod and piston. Those are the only 3 bits that actually move in a 2-stroke engine. So they are incredibly simple. And because of that, they're also very reliable, and either they run or they don't. If there's something wrong, it won't work. But generally, they are extremely simple, and also makes them quite robust. They're quite. I've got engines that are many, many years old. They're really tough. Compare that to the 4-stroke. Here's a 4-stroke. Now, the 4-stroke model engine is just like a car engine in many, many ways. It has a lot more moving parts. We have the crankshaft, we have the connecting rod and the piston, just like on a 2-stroke. But then we also have a camshaft in here, which is driven by gears. And then we have push rods, just like the old V8s, push rods that go up and down, driven by the camshaft in here. And then in tight here we have rockers, so they rock backwards and forwards. And then we have valves and valve springs. So there's a lot more moving parts in a 4-stroke. It's a lot more complex, which means of course they're more expensive, and they're heavier for a given amount of power. But by the same token, they are more fuel efficient, because the trouble with 2-strokes is, if you understand how engines work, you know you've got an intake port and an exhaust port open at the same time, so you lose some of the fresh fuel out the exhaust. It never gets burnt. And these, of course, you don't have the same problem. And of course, these also will produce more torque, because the full power of the combustion is used right down through the entire stroke from the top to the bottom. With a 2-stroke, once the piston comes down part way, and you'll see it here, once the piston comes down to there, you notice that now the port's exposed. So suddenly the hot gases are no longer just pushing on the piston, they're rushing out this port. So you lose most of the power from this degree of revolution, which can be like 30 to 45 degrees of the engine's rotation. There's no power coming out because it's all being vented out the exhaust. So there's little tiny things like that that make a difference. But for all intents and purposes, 4-strokes, you get more miles per gallon. Your fuel tank will last longer with a 4-stroke. That's not always true though, because the Saitos are actually quite fuel hungry. They actually almost as fuel hungry as a 2-stroke. I don't know why, but they are. Yet other 4-strokes like the OS and the Thunder Tiger and this Austrian HP, they are much more fuel efficient. And this engine is a little bit different. This is a 4-stroke as well, but it's I really like this engine because it has your crankshaft, your piston, your connecting rod, but it doesn't have any little valves. Inside the cylinder is the head. The entire head rotates inside the cylinder here, and it's driven by a shaft up the back here, which has a gear up there and a bevel gear at the bottom. So there's no push rods, there's no camshaft, there's no individual valves and springs. It's just a drive shaft and a rotating valve in the head, which makes it very simple. Of course, nothing, there's no free lunches. So it's not very powerful. It's not a very powerful engine. This doesn't put out much power at all. This is a 49 size, a 50 size, but it puts out about as much power. Well, it actually doesn't put out as much power as this engine, this two-stroke. So you can see how, how the two-stroke just puts out more power for a given size and weight than a four-stroke. Simple as that. I want to talk for a minute about lubrication. It's the lifeblood of an engine. If you don't keep them lubricated, then bad things happen and they break, as you can see from my box of broken engines, which I've shown you previously. But in a two-stroke engine, and in a four-stroke, surprisingly, the oil is part of the fuel. As I mentioned, we have three components to nitro fuel. We have the oil, we have the methanol, which is actually the fuel, the bit that gets burnt, and we have the nitromethane, which is simply extra oxygen so that we can burn more fuel per cycle and get more power. So what happens is, normally on a two-stroke engine, we have a carburetor. Here's a carburetor, I'll talk more about that later, but the air comes in through the carburetor, mixed with fuel, goes into the crankcase, and then it goes from the crankcase into the cylinder, and then out the exhaust. So the passage of the fuel through the engine means that because it has oil in it, the lubrication is carried right through the motor. So all the necessary bits get lubricated. The connecting rod, big end gets lubricated, the top end gets lubricated, the piston itself gets lubricated, everything gets a thin film of oil on it, and providing you're using a good oil and you're not running too lean or too hot, the engine is good. Everything stays working. Of course, in a four-stroke, things are a little bit different. Let's take a look at this four-stroke. This is the Cyto 82. If we follow what happens here, the air comes in, mixed with fuel. So here we have our air and fuel, which contains oil, goes into the cylinder head. It gets burnt in the cylinder and comes out the exhaust, but never goes to the crankcase. So how do we get oil? How do we get the bottom end lubed? How do we get the big end and these bearings and the camshaft and the gearing? How does that get lubricated in a four-stroke? You might think, oh, and no, these don't have oil in the crankcase. They're not like your car. You don't fill it up with oil and check with dipstick. There is nothing in the crankcase. And the same goes with this one. There is no oil fill for the crankcase. All the oil is in the fuel. So how do we get the oil into the crankcase? Well, to see how that happens, you have to take a bit of a look at the piston again. Here's a typical piston, and you'll notice that it has a piston ring. It only has one ring. It's not like your car, which has usually three rings. It just has one compression ring here. And as you can see, that ring runs around the entire peripheral. But notice there's a gap. There is a gap there where the piston ring, just there. You can see the gap, hopefully. Is that the right place? Yes, it is. You can see the gap, and if I can hopefully, yeah. Anyway, there is a gap there. So the piston ring doesn't actually seal the cylinder off completely. It doesn't completely stop the air and fuel mixture from escaping to the crankcase. In fact, what happens is a small amount runs through that gap in the piston ring, down the side of the piston, and drips into the crankcase of our engine. So as the piston goes up and the pressure increases, some of it sneaks through that gap, drips down into the crankcase. Now, because the engine is hot, the volatile components, which is the nitromethane and the methanol, they evaporate off, which leaves the oil behind. So once your engine has been running for a few minutes, there's probably about half a teaspoon of oil sits in the bottom of the crankcase because it slipped past the piston ring. And that provides the lubrication for the bottom end. It's a bit like a Briggs & Stratton lawnmower where you have basically what amounts to splash lubrication. As the big end comes round and round, it dips into that oil and causes it to sort of fly up and lubricate the top end, so it splashes into this little pool of liquid oil at the bottom of the crankcase. And that's how we lubricate the bottom end of the four-stroke. So all four-stroke engines, almost without exception, I think, have a piston ring. Two-stroke engines, a lot of them don't have piston rings. If we look at this one very closely, you'll see there's no ring on the top of that piston. That's just a solid piston. So you couldn't use that piston in a four-stroke because there'd be no way for the oil to get to the crankcase. In the four-strokes, we have the piston ring. But you might think then, okay, well, how does it get up here to the camshaft gears and the camshaft? Because if it's just sitting in the bottom and being splashed around, what's going to make it go forward? Well, if you look carefully, there is a little nipple here. This is the vent nipple. Because what happens, of course, because we've got the air and fuel being forced past a little gap in the piston ring, we get pressure building up in the crankcase. This oil comes in here, and also some gases and things because it's high compression coming down the side, so that a positive pressure builds up in the crankcase. And that means that it's trying to get out. We have pressure. And so the pressure moves the oil along here towards this vent where it can escape. So it pushes the oil along here. And on this Sato engine, as it gets to this point, because the crankshaft's spinning very quickly, it also gets thrown up into these gears, which drive the camshaft, and then also migrates onto the camshaft and lubricates the cam lobes. So, and then of course the excess drips out this tube here. So you'll get oil dripping out of this when the engine's running. And that is how the lubrication system works. It's very simple. I'm surprised that it works so well, but it does. It works really, really well, amazingly well. As for the top end here, where you've got your rockers and your valves, lubrication there is basically manual. You take these little covers off and you put a few drops of oil on there now and then just to make sure it's lubed. In fact, a lot of engines, even full-size engines in the aircraft, used to have exposed rockers, and you'd have to come around with the oil can and give them a squirt. Because there's not a lot of movement in there, it doesn't matter. It doesn't have to be constantly refreshed with oil, but you do have to make sure that they're lubricated every now and then to stop them wearing out. Now, this 4-stroke engine operates just slightly differently, very much the same, but we do get some blow-by on the piston ring, which puts oil into the crankcase, but also here, you notice there's this pipe from the muffler. Now, when the engine exhausts out there, there's oil in the exhaust thing, and this muffler collects some of the oil and pushes it back down here into the top. So it comes in here and it runs down there, it lubricates the gear in there, and it lubricates the gear down there. So the exhaust pressure pushes that through, you got the blow-by on the piston, and again, it runs forward and out of the breather nipple. So if the breather nipple ever gets blocked in your 4-stroke engine, you're in trouble, because the crankcase will pressurize, there's nowhere for the oil to go, and it will run very poorly, very, very poorly indeed. So as if you're using a 4-stroke, you always got to check, make sure that nipple is clear. And especially if you've had the engine laid up for any length of time. This engine was run with castor oil, unfortunately, and now it is solid because the castor oil is all frozen. It's not rusty, it's just frozen, and that little nipple there has been blocked off with some jellied castor oil. So I'm going to have to strip this down and clean it up before I can use it, which is a real pain. I used a good quality synthetic in this, and it's smooth as, it's just like nothing happened. So again, if we want to talk briefly about oil, traditionally we used castor oil in these engines because it was all we had, because ordinary mineral oils will not mix with methanol. If you try and mix your 30W50 with methanol, it just sits in the bottom, so it won't mix up. So you need a special kind of oil to mix with alcohol fuel. And castor oil was readily available. It has a number of really good properties which make it very suited for this kind of application. So we used castor oil, but it has some downsides. If you look at the muffler on this engine, the fuel I was running in this engine had 2% castor oil in it, and look what it's done. It's varnished up the muffler. This is supposed to be shiny metal, but it's covered in a kind of a varnish, a lacquer, that is actually castor oil that has just got hot, and it does what's called polymerizing. It turns from a liquid into a solid, but it's kind of like a plastic. It's a polymer, and that's one of the good things about castor oil. If you run your engine too lean and it gets too hot, instead of just vaporizing away into nothingness and allowing metal-to-metal contact, castor oil will leave a deposit behind which actually acts like a thin layer to stop metal-to-metal contact. You can probably see it on this piston actually. This has had castor oil in it too. You can see this black here. This is actually polymerized castor oil. So there's no metal-to-metal contact, even though this engine has been run quite hot, and it's left a bit of black on the top as well. So we used to use castor oil for those reasons, but then synthetic oils came along, and now there are some really good synthetic oils on the market which don't suffer from the problems of castor. One of the castor oil issues is when it's cold, it's like treacle. It's got a very poor viscosity rating. It gets very, very thick when it's cold. It gets very thin when it's hot. So synthetic oils have much better viscosity consistency over temperature. And synthetic oils also do not crud up your motor. They leave them nice and clean, but on the downside, they don't provide as much protection ultimately in a lean run, and they can cause corrosion issues if you're not careful, especially stuff like cool power. I'm not a great fan of cool power oil. It can leave your motor rusty if you hang your motor up without giving it a bit of a rinse out with a decent oil. But yeah, it's pretty much your own choice as to what you use for oils. And we use oils, you remember the old, if you've got a lawnmower or a chainsaw or something, you're probably mixing oil about 30 or 40 to 1 with the fuel. These, typically, especially the 2-strokes, traditionally it's been up to 20% oil, up to 20% oil when using castor oil in there to protect the motor. That's a whole 1/5 of your fuel is actually oil. That's why they're so messy. People say, oh, they're slimers, they throw oil everywhere. Yeah, if you're going to use a very low-tech oil, a very cheap oil, then you're going to have to run a lot of it to provide protection. And in the case of castor oil, that's about 20%. If you're using more advanced synthetics, you can go down to about 12%, which is a whole lot better. You can almost halve the amount of oil, which means they run a lot cleaner. I use a European synthetic oil in some of my motors, and there's no oil left on the model at the end of the day. It is just because you place the exhaust in the right place. The model hardly needs to be cleaned up at all. You use a high-quality synthetic oil that works really well. So there you go, that's fuel. Now, one of the great things about Nitro today is you can pick up old motors really cheap at, garage sales. You find motors, they go for a song. People give them away because everyone's gone electric and they don't like Nitro. So you can pick up some really amazing deals on the second-hand market. And if you do that, you probably want to know, okay, probably I need more than just an engine. What else do you need if you want to go and just build a nitro plane just for the hell of it? Well, I'll tell you, you're going to need the engine, right? You're going to need an engine, whether it's a 2-stroke or a 4-stroke. And if you're not familiar with engines, you're probably going to be better just to buy an old 2-stroke from somewhere. You know, there may be a K&B or a Fox if you're in America, or an OS. OS make good engines, they're durable. You know, you can't really go too far wrong if you buy an OS engine, especially the FP series, which is from the 1980s. They were really good engines. I would recommend them to anybody. They're plain bearings, so there's no ball bearings to go rusty and to need replacement. They're just a bushed crankshaft, really, really basic, very simple. So if you can pick yourself up an OS FP engine, great way to go. They had an FP29, the FP40. They were just brilliant. Or FP60, they're all good engines. If you can get one for 10, 20 bucks, hey, it's a steal. So do it if you want to have a play with nitro. So you've got to get your motor. You'll probably want to get a new glow plug because they will over the years they just oxidize and things. So get yourself a new glow plug. And if you're looking, what glow plug do I get? OS number 8. You can't go wrong with an OS number 8. Get that. You're going to need some way to make the glow plug glow. So you get one of these glow clip things. There's all sorts. You can get them. They look like they just clip onto the top of the glow plug. You can buy all-in-one glow starters which have a battery in them, and you hook them on. And this one has got a lead on it. It's really old and tired and it needs repairing. It has a lead, and I put a Dean's plug on it. And you need 1.2 to 1.5 volts to energize these plugs. You can't use 2 volts. They will go pop. And you can't use a LiPo, a lithium cell, because that's 4 volts. That'll just blow them up. So I use 2 NIMH batteries that I had laying around, wired them in parallel so I get more current out of them. You don't want them in series, you want them in parallel, just 1 point. So you can get a couple of inner loops, a couple of inner loop NIMH batteries, solder them together in parallel. That'll provide plenty of starting power. I've put a little clip on here so I can charge it easily, and I just plug that in there. Then this goes on the glow plug on the motor for starting, simple as. Once the motor's started, of course, you disconnect this and it'll keep running. There's no problem there. But you'll also need a fuel system. So you'll need a fuel tank. There you go. And they come usually like this with basically a set of plumbing, and you put them together. They have a little weight here, which is a clunk, which basically means it doesn't matter whether your plane's up the right way or the wrong way. The weight will cause the fuel pickup to drop to the bottom side where the fuel also is. They have a little bung in the front. And so you put those together. You need some fuel tubing, and it has to be silicon. You can't use rubber because the fuel will rot rubber. Rubber is no good for glow fuel. You want silicon fuel tubing. That's cheap as beans. You pick some of that up. And then the fuel tubing, there's a nipple on all these motors where the fuel connection goes. It's pretty easy to identify. On this engine here, there's the little nipple. On this engine here, there's the little nipple. On this one, there's the nipple. It's pretty easy. It's on the carburetor or near the carburetor. Easy enough to find where the nipple is. And if we look at the only time you won't find a nipple is on a carburetor like this, because sometimes we have a remote needle valve, which you're probably unlikely to encounter with a second-hand engine, but sometimes the needle valve is mounted right at the back and there's just a tube goes to the carburetor. You don't have to worry too much about that. So that's your fuel system. You'll need some fuel, and unless you want to go buying ingredients, just buy some fuel. I'd start with something like 10% nitro fuel. You don't need too much nitro. 10% is more than enough. You can just pick up some cool power. Although if you're running a plain bearing engine like the FP, get yourself the Omega, something with a bit of castor oil in it, because that's actually a bit better for bushed engines. Where you don't have actual real bearings, castor oil provides extra protection that's really good. So get yourself, if you're buying the Morgan's fuel, then buy the Omega, which has got some castor oil in it. Really, really useful. Otherwise, just get what you can get. But not too much nitro. You don't want to get too much nitro. You'll also need a propeller. I thought I should mention this because we're all used to electric power and we have these electric props. Nitro props are actually a lot more robust. The hub, where the blade joins onto the hub, is much thicker and they're much stiffer because electric provides a smooth, consistent torque. It just, the torque is constant right around through 360 degrees. But internal combustion engines provide pulses of power. In the case of a two-stroke, you get 1 pulse per revolution. When the engine fires, suddenly all that pressure on the piston, and suddenly you get a massive burst of torque on the crankshaft. So these things have to be pretty strong to stop them from flexing and bending under the torque loads. And in the case of a 4-stroke, it's even worse because you get an even bigger pulse of torque, and it only happens once every 2 RPMs. So it's more concentrated. It's a larger amplitude of pulse. And if you use the wrong prop, then it'll just fly apart. It'll break because it's not strong enough to withstand the torque pulses. So that's really don't use an electric prop on an internal combustion engine. You will just be asking for trouble. It'll shed a blade, and once you've shed a blade, then the offset vibration will rip the motor off the firewall, and if you're standing nearby, you could actually be badly injured. So don't do that. Absolutely don't do that. Yeah, and you might want to get an electric starter. You don't have to. These things, if you set them up properly, they are so easy to start. I've got Thunder Tiger 46s on some of my planes, and even after years hanging up, 3 chokes, 1 flick, and it's running. Simple as that. If it won't start within a couple of flicks, you've got something wrong. You've got either too much or too little fuel, either the glow plug isn't heated up, or there's some other fault with the engine. So you don't, if you have to flick for half an hour, you've messed it up. And usually what you've done is you haven't got the mixture quite right. So the needle valve, generally speaking, rule of thumb, to start an engine, that is an engine you don't know, open the needle valve between 2.5 and 3 turns. That's probably going to get you in the ballpark. It will run at that setting. It may not run very well, but it will run. Once the engine's running, you can adjust that needle valve to get the engine running smoothly. So yeah, 2.5 to 3 turns is a starting point from fully closed. Hopefully that's useful. Now, while we're on the subject of fuel systems, most of these engines have a pressure tap on the muffler. Now, this is a 2-stroke muffler, and this goes onto the side of the motor, and here's another little nipple. This nipple here is to provide pressure. When the exhaust gases come into this chamber here, they tend to build up a pressure inside the chamber, and because the carburetors on these nitro engines don't have a pump, they can't draw fuel very far. So if your tank, for example, was a long way away from your motor, then when the model nosed up, gravity would hold back the flow of fuel, the engine would start to run lean, it might even stop. So to reduce that effect, there's a pressure tap on the muffler, and you take a silicon fuel line from there back to the tank, and that pressurizes the fuel tank so that you've got not only the engine sucking the fuel to the carburetor, but it's also being pushed by the exhaust gases as they come out of the muffler, and that provides much greater dependability and much more evenness of running regardless of the attitude of the model. So yeah, you'll get a nipple on there, and on this one there's a nipple on here, and most 4-stroke engines have a nipple on them. Here's one on the Cytos on the side there. So these little nipples on there are used to pressurize the fuel system to make it more reliable when it's running. But one thing to note here, it's quite worth considering, is although the 4-stroke engines tend to be heavier for a given power than the 2-strokes, they can use much smaller mufflers. Look at the size of that muffler compared to this. And well, let's go to the Cyto actually, because this is an 82. This is an 82 engine. Look at the size of the 82 4-stroke muffler, and this is a muffler off a similarly sized 2-stroke. Look at the difference. And of course, that 4-strokes don't need big mufflers because they're only firing half as often for a given number of RPM, so the noise immediately is lower. And the frequency is lower, so it's less irritating. So this is the difference in muffler sizes. So what you gain, or what you lose by having a heavier motor, you gain by having a lighter muffler. So it all balances out in the swings and roundabouts. And 4-strokes, towards the end of the reign of Nitro, 4-strokes became very, very popular and more desirable than 2-strokes. But if you're buying a second-hand one, there's more that can go wrong with a 4-stroke. So just buy yourself a cheap 2-stroke to get into Nitro if you want to have a go, have a blast, see what you've been missing. And one last thing in favour of the 2-strokes as well is that if you want to, you can significantly increase the power with one of these, a tuned pipe. Now 4-strokes don't respond very well to tuned pipes, you don't get much gain out of them, but with a 2-stroke you can get up to, depending on the design of the engine, you can get up to 40 or 50% more power just by adding a tuned pipe. That's amazing, and they really excel with a tuned pipe. And in some cases the tuned pipe is lighter than the factory muffler. So yeah, that's another reason to get a 2-stroke, and see if you can pick up an old tuned pipe. You can even make them yourself if you've got some basic skills. This, for example, is a 60 size, which is slightly too big for this motor, but I do have a smaller one on my combat wing. And it's like night and day. It's like turbo. It's how you turbo a 2-stroke is you put a tuned pipe on it. Simple as that. So yeah, and the one thing you find with Nitro is once you start fiddling, once you start realizing how much you can do with these little motors, you can play around with fuel, play around with plugs, play around with propellers, all sorts of things, different mufflers, tuned pipes. It is just a whole hobby in itself. And if you're a bit of a gearhead, if you're a bit of a petrol, a bit of a gashead, then it is a whole new element of the hobby that has really sort of died away because people have just gone to plugging batteries into ESCs into motors, and there's not so much fun in that. So I really highly recommend, if you want something to do, especially maybe over the winter in the Northern Hemisphere when, you know, there's not so much flying opportunity, just keep an eye on eBay or your local flea markets or garage sales. See if you can pick up one of those OSFP motors and have a play. Just put it on a plane for next season, and I think you'll be pleasantly surprised at how much fun you can have. And the beauty of it is that you don't have to have a big stack of batteries. If you put yourself a decent pack in your glow-powered plane, you can fly all day. You take off, you fly, you land, you refuel, you take off, you fly, you land. No charging involved. One charge will last you all day, and you can fly miles away from the nearest charging outlet because you're just refilling a tank, refilling a fuel tank with fuel, and you can keep flying until you get tired or bored. But trust me, you probably won't get bored. There you go, that's it. A little look at nitro engines and some of the magic involved. And if you've got questions, comments, put them in the usual place. I wanted to do this video just to change things around a little bit because, as I said at the beginning, a little bit tired of the same old stuff, and this is not really the same old stuff, is it? Now, as I say, if you've got questions, I'm more than happy to answer them. And if I've got a couple of models I want to build here for the summer, and one of them will be a nitro model. So if you want to see a build, a nitro build, because it's actually quite different to an electric build, if you want to see how I do the plumbing and the different servos that we use and the way we set up the flight system, the receiver and everything, then let me know. And I will do a build video for a model I've got out here, and I'll put it up on the channel, and you can see, it might give you some guidance if you decide to get into nitro yourself. There you go, folks. Thanks for watching. Thanks to my Patreon supporters. No mid-rolls. Yes. Woohoo. Okay. Bye for now.